Hello.
Hello, what's up?
This is the easy explanation video for 471B and Easy Vexy.
Yeah.
Easy robotics. Robotics is easy.
We all lost in semis.
Yeah.
It's fun.
Yeah, and we all ranked third.
Yeah, third.
So I'm Gil, this is Evan and Lucas.
Yep.
We'll start with Evan's spot.
I'll start with the drive base for our robot. So we ran a generic 450 RPM 3.25 inch wheel drive base. We ran a really long drive base. It was 34 holes long, just because we wanted our Rig 1 style robot to be able to hold as many balls as possible. We had an 8-ball capacity at Worlds. The length was kind of bad for driving through alleyways, but just like driver diff, it was really fine. We had logo funnels here that extended down with triangle braces. Same thing for long goal liners, and then we had a C-channel with just a piece of poly on it. For every wheel and idler gear on our drive base, we ran a structural screw joint, which is just a screw going through with a caps nut and then an aluminum nylock that just tightens everything, so it's all really strong and secure. We use shoulder screws for all of them too, so the wheels are centered. In order to fit this wheel here, we had to sand down this caps nut at the very base there. I don't know how, right there. We just sanded down the caps nut in order to fit the wheel in this 5-hole gap. We tried using flat heads for the entire side so that we'll have more clearance for descoring with our wing. And we just ran 2 cross braces going all the way across here. 1 steel screw and 1 aluminum screw to save weight and to be really structurally sound. And lastly, I guess we had wall riders on the sides of here, where these were actually boxed with, here you can see, this is an aluminum spacer that you can buy off McMaster. It's really thin, but it's still really strong because it's aluminum. And then we kind of just put the shaft collar like this, and it spins really nicely. So we had them on every side of our bot, which helped with autons, I guess, if we ran into a wall, driving in general, and just going through alleyways. It just made everything better.
All right, so this is the Easy 24-inch robot. If you look at the drive, it's 600 RPM, 2.75-inch direct drive. So this is a very nice ratio to run on 8 motor. So you can see that our motors are mounted on these PLA 3D printed brackets that are custom made, and the motors are all at angles, which allows for easy access to the ports and also to replace the motors easily if they break. I can pull this off like that and the motor will just come off. You can see each of the motors are just connected 1-to-1 with these also PLA gears. We know that a lot of teams have had problems with breaking 3D printed gears, but we actually haven't had any problems with that. We're not exactly sure what we did that made them so good, but what we do is they're only an 1/8 inch, but we use very large tooth size. And we also try to stick with close to a 1-to-1 ratio. In this case, it is 1-to-1 because it's just 600 RPM. And additionally, we use very thick wall layers, and we use gyroid or TPMS infill. Like 20%, 25% infill, and walls thick enough that the entire region of the teeth is solid. There's no infill in there. As you can see, we run 6 Omni wheels, 3 on each side. This is important for weight distribution because if you put, this robot weighs around 18.5 pounds, and if you put all of that on two wheels on each side, you can start to have problems with your Omni wheels digging into the field. It probably isn't an issue with these harder Vex 2.75 Omnis, but it was a problem when earlier season we were running custom Omni wheels. Additionally, you'll see that we have these extra 2 wheels. These are smaller wheels, I think they're 2 inches, and these are custom molded from polyurethane. And these are just for helping us get over the parking barrier in order to double park. And also to help with that, we have these 3D printed sleds here, which you can see make a smooth curve up to the sort of circumference of the wheel. And that helps us get a really smooth barrier cross so that we can double park very quickly. Another thing, you'll see our brain mount. This was kind of annoying at times, but also really nice at other times because it takes up basically 0 space. Having the brain under the robot like this is actually legal, even though it might not seem so if you look at the inspection sheet. And the reason is because we have our battery cable exposed very easily on the side of the robot, and as long as either the brain power button or the battery cable is accessible without lifting the robot, you're fine. One more thing on the bottom of our robot, you'll see we have a custom ODOM pod. This is a custom 2-inch I think 2-inch traction Omni wheel made with rollers from the 3-inch Omnis. And then we have a encoder. This is a very low profile optical encoder from CUI Devices, which we got on Mouser Electronics. It's wired to 2-3 wire ports the same way that the old ADI encoders were. The resolution isn't quite as good as the ones that Vex sells, but it's more than good enough for our odometry to be consistent. Another little thing we do here that some people asked about is we have these empty wire heads covering all of our empty ports in the brain. And this is just to prevent dust from getting into the ports, which is really important when you have the brain sticking out at the, well, not sticking out, but facing the bottom of the field at the very bottom of the robot like this. You'll get a lot of dust on it. And so it's important to make sure that doesn't get into the ports and damage them if you want your brain to last long term. Another thing that's important when you do this, you have to crimp these heads, even though there's no wire in them. If you don't crimp them, the little metal pins will push the metal pins in the brain in and can actually damage them. So if you try putting a wire in there in the future and you don't crimp this, it's gonna cause problems. You might have issues with your wires not connecting properly. And the last thing I want to show on my drive base is our wall riders. These are pretty simple, but they worked really nice. There's just a little ball bearing in there that's around a 1/4-inch aluminum spacer. And then this is a 3D printed little roller that press fits around the ball bearing.
So on the 15-inch, it was basically the same as the 24, except with like a few different details. It was also 2.75 Vex wheels, 600 direct, 8 motor. But a big difference I had is one center traction. This was molded with polyurethane. This is also a 2.75-inch wheel. So how we made an all Omni drive with a 2.75-inch traction is that this is actually in the center, if you can see that. But the inner drive braces are a 3-wide. So I had to drill a hole in the exact center. And I do this because it's a lot nicer to have vertical motors like this, which is just good for fitting everything. We had the space to fit an odon pod, and like space was really a big problem on this bot since it has to start within 15 inches. So another thing we have on the drive is on these 2 cross braces, I have one standoff connecting the 2. This just makes it like super strong, and then boxed as well. We did have it on this side as well, but then the odon pod kind of got in the way. One big thing we had for the 15-inch was these side skirts. It's sanded down 1/8-inch poly. And this is just really helpful for like sliding against people. I never got like stuck on anyone. And when people were trying to push us, because we have all Omnis, it's really important that you get away before like they push you too far. So I had this bulged out in the center by about an 1/8 inch. That way, when someone hits us head on, I still have room to turn and then get away pretty easily. Because a lot of the time, what happened like earlier in the season was when someone was pushing us, we were just stuck like this, and they were like just pushing, and we couldn't get away because like they were just contacting like a whole flat side of our bot.
That was especially a bad problem because we had traction wheels at the start of the season, really good traction wheels, so our robot wouldn't slide at all, so we just kind of get stuck there when somebody pushed us.
Yeah, and at Worlds, no one could really push us.
Because like it's so easy to drive away with those side skirts.
Yeah.
They're not side skirts, but side plates.
And then it was also really important to have these screws be as flush as possible. That way nothing gets stuck when someone's trying to push us.
Okay, so moving up from our drive base, I guess I can talk about our match loader first. We just ran like a generic match loader, just a poly piece that's able to pivot. We had it on zip ties because when this was back, like I said earlier on the drive, we had a 17-inch long drive, so we had almost no room to make anything longer. So our match loader had to be really compact to be in size, but it was close to the intake. So we mounted on zip ties so we can just be flatter against the iron string shaft. Standoffs here that helped funnel balls to go in. So it goes in one lane for skills. And we had a series of aligners here. So our triangle braces, we had zip ties on them, and those were actually really good for aligning into the match load tube. If we were off here, it would kind of shift to the side. And then we also had aligners on our poly piece. A lot of people ran this design, and we actually came up with it early season in like around December 2025, where it would align to this inner edge of the match loader. That way we have this a very consistent match loader liner, and we can be straight basically every single time. Of course, we use whimsy nuts because they're good, and these half cuts here. We triangle braced. We hard stopped it using these like bearings that are 1/8 of an inch on these nuts, so that it could just rest nicely. And then obviously we had a single acting piston, so it uses less air, tucked away back here. And then moving on from our match loader, we have our entire intake system. We ran a 22 watt intake that was able to hold balls, up to 8 balls, and then we can score them using a PTO. One interesting thing was that we actually mounted our motors really, really low here. So they're actually inside of the intake ramp. And that basically made our cog really, really low. So we're able to drive forward and back really quickly without tipping as much. Over here, I just took the license plate off. That took a little bit. But as you can see, the motors are mounted at an angle. We have this 24 tooth, I think, that's geared to the 16 tooth. So we run a 900 RPM intake. Yeah, the friction was generally good. It was very low and tucked away. And having our motors down there means, like I said earlier with our cog, we also had our tank and all of our drive motors, battery, and brain really low down to the ground for a good center of gravity. We ran these McMaster-Carr Teflon nylon washers that covered the end of the sprocket. This made it so this chain wouldn't be able to fall off even though it was really loose because of lower friction and spacing wise. For our intake, we just ran a normal conventional pivoting intake. But like I said earlier, because of problems with keeping everything in size, the only brace we could do was this 3-wide that we cut into a half cut. And we actually put a drilled standoff inside of it. That's what these tiny nuts are. These are 440 screws that we just drilled a small hole through the standoff to put them on. This makes everything really strong, and as you can see, this doesn't pivot. It did bend slightly at the top here, but it was fine for most of worlds. We ran half-cut flex wheels in the middle because they made our logo and match loading much better because the balls could just flex out of the way really easily and really nicely to be able to intake balls. The ones on the sides were normal flex wheels because it helps funneling them in better. Just like that. The flap rollers took a bit of a while to tune. We used to have flap chain going around like a normal Raguan bot, but we didn't like that because at a few competitions, the chain would sometimes break and our intake wouldn't be able to pick up any balls at all, which just completely screwed over our scoring. So we changed to these rollers with chain going in between them. We ran 3 rollers. The middle sprockets are actually bigger than the outside ones. This actually helped a lot with funneling and scoring because as the middle ones were stronger and thicker, that made it so balls had a lot less compression and was like a lot tighter to go through, which actually made our scoring faster because it shot the balls through. But when we held balls in a 2-wide position, the smaller sprockets on the outside made it so the balls funnel in easier because we don't need the scoring to be necessarily strong on the sides. We just want it to funnel in towards one lane. And what helped with that was with our compressing funnels. We had a latex tube in between them to help them just compress inwards. They were just made out of 2 8-inch pieces of poly. One interesting thing a ton of people asked questions about was our logo funnels. So as you can see for the bottom of our bot, we had these 2 hard-mounted funnels that are actually mounted on rubber links here. That made them really, really compliant and squishy. And it allowed us to be able to, when we intake balls, it would just be compliant, like I said earlier, and balls could just go through really, really easily like that. But then when we were outtaking, it would stop because of the force of the other piece of poly at the top, and the balls would just funnel in at one lane. We were able to score 7 balls in logo with this, alongside this piston we have mounted on our intake that could just lift it up very slightly for better logo scoring. So we can get, theoretically, we could have gotten a 119 driver, except I kind of sold with mid-goal. The logo scoring was actually better than our mid-goal scoring, which is why we ran right side more during matches. Going back up here, we have this band roller that just helped speed up scoring at the very top because we didn't need as much compression there. And one interesting thing we did was we would have ran 3 band rollers at the top, but we decided to run flex wheels here because it helps funnel balls in a lot better. The biggest thing about scoring fast with the Raguan bot is you want to be able to funnel everything into a single lane instead of having 2 as fast as possible. So the flex wheels actually really helped because if a ball were to go underneath one of the flex wheels, it would want to go to this really big gap in the center. But if we had a band roller there, it would stay on the side. So by just using flex wheels, the balls tend to go towards the center a lot more. And the way we activated this was with the PTO. I was just able to shift in so we were able to score and then go out so we were able to hold balls. We had this really funny looking gear lock here with just standoffs going in. And this stopped this top part from spinning, which made it a lot easier to hold a lot of balls. Just like that. And then when we activated the PTO, we use these beveled gears to just shift in, and then the balls are able to easily and smoothly just spin out like that. For the end of this, we just had a normal conventional hood. We used to have this on a live pivot, actually on the shaft, but that was really bad because it added a lot of friction to the intake as the hood would pull down with a lot of weight. So what we did was we mounted on a screw joint before Worlds, and we used this drilled standoff triangle brace to be able to brace everything and make this really strong, because if this gets hit really hard, the brace will just keep it stable. For every single one of our bearings on our intake, we had them all loose and wiggly. So you can see here, this can wiggle, this can wiggle. These were drilled out bearings that could wiggle. The bottom could wiggle really easily. And we did this because it was self-fixing friction. Thank you to 3D4C for the idea. We kind of stole it from them, but it basically, you mount a pillow bearing on a screw joint and it's able to wiggle, or you just get a normal bearing flat and drill a hole through it. This reduces friction, reduced all of our friction by like 5 watts, I think. So it actually made it really, really, really nice.
So for the 15-inch, it's a very similar design as Evan's, but big changes had to be made. One of them, it had to be in size and 15 inches. This was super hard to do. This thing is like a brick. It's 18 pounds and it's like super dense. But the first big thing we had to figure out was how to do the intake and match loader flip out. But we still wanted to do like undergoal and good scoring. So we wanted the lift 4-bar to be as long as possible. So we came to this design where we have, it might be hard to know what you're looking at until I flip it out, but we have the intake up like this, and then the first set of flaps are flat. And then we have the match loader tucked behind the intake. If you can see that, like this is the match loader. So when I put it in size, I have to put it in enable, but this will flip down, the flaps will push it down, and then this will come out. And we have this like lock right here, so it doesn't go back into the flaps. But when we start the match, you just pull this up, push it in. We have it attached with a rubber band. That way, when it goes down, it also pulls this down. And then there's a little bit more compression up. One big problem we had was because everything had to be super compact, this had to be mounted outside of the intake, and we wanted the intake as long as possible to have like more pickup range. But one problem with that was that like there's barely any clearance between the match loader and the intake. So that was really annoying, having to get like this to just go down. We actually lost win point. We would have been second in rankings at Worlds if this went down in one of our matches to match load, but we lost 1 point from that. The match loader is pretty much the same-ish as like every other match loader. Pivoting plastic, hard soft with these 3D prints. Then we mounted it on a 6061 aluminum shaft. That was just super strong. This never bent or anything. Just also a lot lighter than a steel high shank shaft. So for the intake, we had a lot of fun things with this. First, it's mounted on poly, 1/8" poly. That way, like if it ever bent, it couldn't really bend, but if it ever did, this would just like bend and then come back. Then we had PLA arms that we made. The pocketing is just for fun. I don't think it really did anything, but this like never broke. It was never a problem. It kind of got like scuffed up from people hitting it, but that was kind of it. On the shaft itself, it's actually a polycarbonate tube. A lot of people asked about this. It just like really makes the bot lighter. There's not like a high shank shaft here or whatever. And it's also very flexible. Like I can just do this and it just comes back right there. It also lets us like mount stuff directly to it. We just drill a hole and then tap it and put a screw in it. We also had these optics. They're from FTC. Does this a lot, but it's just like a lot more grip than flex wheels or Vex flaps or anything like that. So if I have a ball like right here, it just goes in. It's super grippy. It doesn't like slip at all.
It's a lot more compliant than the flex wheels. It sort of handles these kinds of balls a lot better. The flex wheels really weren't very good at this. Well, flex wheels kind of didn't work very well at all. Normal flex wheels, unless like if you get the geometry exactly right, it works good. But we found that these silicone tube flaps were extremely good and required basically no tuning.
The one bad thing about it was that they broke. Like you could see right here, our smaller one on the side broke. It's just kind of annoying. You gotta just replace it, but it's just like better, so it's kind of worth. We had a like very strong 6061 1/8" aluminum bar. This was really good for, I play a lot of defense, and when I'm running into people, this like never bends. It's like super strong. So when you go up to the intake, we have these flaps. They're actually made out of TPU. We didn't really see any other VexU teams do TPU for flaps, and it's just like so good. It's super flexible. You can tune how thick it is for how like compliant you want it. We didn't really have any problems with it or anything. We just had to figure out like how long it had to be, how thick it had to be, but that like didn't really take that long. We also have rubber band span on the bottom just for a ton of compression, and if one band ever broke, like it wasn't really a problem. It's pretty silly to look at, but it worked well. So one annoying thing is that we have the battery inside the intake, like right here. It's super hard to see. This was really annoying, but there was literally no other place for it. Like we had basically zero room on the sides. On the bottom, there's the tank right here. It couldn't fit there. It would get hit right here. Like the only alternative would be to make the tank smaller, or to have it like flat on the side, and then it like could get hit or something, and we didn't really like that. So we have 3 motors on the intake. We originally just had 2, like Evan's there on the bottom for good center of gravity. It just really helps when you have an underbar Ruban. It's like can be super tippy, especially with this when it's like so short. We were having like trouble with jamming and funneling and everything like that, and like instead of doing it the right way and fixing those problems, we just slapped on another motor.
Bruh.
This worked super well though. The scoring like instantly improved. Obviously we did tune friction. The friction's pretty good. It definitely could be better though. The funnels we have here are just hard mounted. They're pretty flexible. It's 16th plastic poly. There's zip tied on the bottom, and then on standoffs on the middle. I didn't really have to like tune this at all. We were scared that funneling and the funnels were gonna be like a big thing, but like these just worked fine. When it got to the top, we just had this band roller, and we found that the less bands on it, in this case 2 bands, the better. This just let the balls like skip pretty well, like that, not really get pushed, but just have enough where it could still like hit this roller. And we have the intake on a PTO. So there's a piston under this bar right here, attached to this gear that we like sort of beveled. It basically just like shoves itself in like this. The only big problems we had with this was like gear meshing, which we just like reprinted gears, and then the brass inserts that's in this, like how it slides, the super glue came out somehow, and then sometimes it would just get stuck engaged. That was like a problem when we were doing skills at Worlds, but it was pretty easy to fix. When we score, all it does is it just like jams itself in there and then spins really fast. The speed on all of these are like really funky. This is a 1-to-1, so all of this is 600, and then this is a 2-to-1, so this is like 1200, and then it's like a 1.6-to-1 down here, and then these gear trains here, these are like 20/19, and then these are 20/18 for spacing. We had a counter roller right here, just because it made the compression like scoring into the middle like really good, and it also made it so we didn't have to have any like roller on the hood, which was pretty nice.
And with that combined with the bottom roller, ended up being enough to shoot a ball all the way through a goal and have it fall out the other side.
We should show it.
So when shooting it to the other end, it really didn't do it consistently. It like the hood, the how much air I had, all of that like depended on how far it would go, but it was still pretty good. Before Worlds, I knew that the goals were going to be newer, and with the newer plastic, it's kind of like sticky, so the balls don't like go in all the way. With this bot, I tuned the scoring to be like better than it should be, or like go further than I wanted it to. That way at Worlds, I knew that it would be a little worse and it would be like good enough.
Continuing on from what Gil said, I also tuned my intake to be able to shoot balls through the goal because the goals at Worlds were sticky. So we were able to consistently score through the middle. Here we tried shooting it all the way through the goal. The way we did this was, first of all, we cut these flex wheels out, so the balls were able to squish more, which means they were able to go up higher, which means the balls didn't hit the lip of this goal, they could just go up really easily. And we also cut out the C channel, but we kept the flange. This makes it basically the same strength, but it makes it so the balls don't hit the C channel at all, because when they would hit the C channel, it would slow down the intake a lot. And the biggest thing we did was with these band rollers here, similar to robots in the zone, I think, where they had like the X pattern. We took inspiration from that and I just put that on our band rollers. It doesn't make it compliant at all. It's really, really hard to push down. That's because it's like two bands on top of each other. Instead of just having two bands like in a row like that, each of them would be like the same squishiness, but by combining two of them, by making it an X, it makes it really, really strong and squishy. For the most part, it could shoot through the goal, and it was pretty nice.
We did the same thing on our top roller, and I can confirm that it worked quite well with the zigzag rubber bands.
It also looks cooler.
It does look cool.
That's true. That's pretty true.
It makes like a hyperbola, and it's pretty sick. I recommend it. All right, so the intake on the 24-inch is more or less the same as the 15-inch. You can see we have the same polycarbonate shaft. The match loader is also basically the same, except built a little nicer because we didn't have to cram it in such a tiny space. So it's just kind of a little bit cleaner, and it works very well. The corners on it, these parts sort of helped us align to the match loader. So again, this intake shaft is on these sort of 3D printed mounts. This one doesn't move at all. It's not like the 15-inch where it can move up and down a little bit. This one's completely hard mounted, but because these tubes, oh, this one's broken, but because these tubes are so compliant, it actually didn't have to move up and down at all. Also, we have these tubes on these little plastic ball bearings. They're just ball bearings with a plastic housing, and these are extremely light and very low friction. And then for the rest of the intake and scoring, it's a little weird. Some people describe it as kind of an upside down Raguan, but it's actually pretty simple. So we have another like normal roller here. These are the TPU flaps that you saw on the 15-inch. I put some latex, or not latex, silicone tubing on these, zip tied it onto these just to add a little bit of grip because I was having problems with the dead zone there. And then above that, there's a few band rollers. So this brings the the balls up to here really nicely. And then we reach this pivot point in the middle. And this is where the lift pivots up and down. So we have the joint on this mounted concentric to this shaft, which means we didn't have to have any sort of chain tensioner anywhere on this. And you can see on this shaft, we just have some small flaps, and then we have chain flaps that just goes all the way over to the scoring at the front. And when we're intaking, these move very slowly. And this allows balls to go into the front, but prevents them from coming out at the end. I'll talk a bit about the indexing a little bit more later, but that helps a lot with indexing. But when we're scoring, it moves full speed and goes quite fast. And then this, you'll notice that I actually have 3 sets of chain here, and this is some old tower takeover tech, which is you can, when you're using chain flaps to make them really strong, what you can do is add additional 2 sets of high strength chain around the outsides so that the chain can't really twist either way. It works even better when you're using like the full flaps, like, or not flaps, but the tank treads, so that every single one of these links is like supported, but it still works pretty well when you only have like the occasional flap and it's only like actually helping support where you have those flaps. But this prevented this chain from breaking. I think it broke like once in practice, and that's it. And that was really important because if this chain breaks, I can't really score, or at least not very well. We didn't do anything fancy for the funnels on this robot. It's just a slow and gentle curve inwards, and that was enough for it to actually funnel quite well. You can see the balls, they sort of slowly make their way up to the top while I'm indicating, and then to index. Like I mentioned, this bottom chain runs at a really low power when I'm just intaking, and so it ends up completely stalling when there's like more than like one ball in there. And then this top roller here just spins in reverse, and that keeps this ball from coming out. So this ball is held in pretty well, and it never falls out. And then when I want to score, what happens is this bottom chain will run at full power. It's powered by 2 motors down here, and this top roller, which is powered by 1 motor up top, will run forwards. It will score them pretty quick, just like that. So if you're wondering why this is so weird, like why we have the scoring on the bottom instead of the top, it's because originally this robot actually was a double intake robot. So when this was down, it could intake balls from the front right here. These were larger, these were 4-inch flex wheels that were flapped. So that would act like an intake at the front. This aligner thing wasn't here, and it would intake, they would go up here, and then they could come up through like a hole right here. But we ended up getting rid of that because it really wasn't very useful, and it was causing a lot of problems with scoring. Like our balls were kind of getting jammed in the middle. So we just got rid of the front intake ability and made these flex wheels smaller, solid flex wheels, and that gave us really good scoring, and completely fixed all the issues with jamming, and like really had no downsides because double intake wasn't very useful in the first place.
That's also why the brain is facing the bottom. It's because we had no space on the sides to mount it, and this was like a ramp for balls to go up like that.
You might have noticed these weird plastic sort of slides here, and these are also just 3D printed PLA. And what this is originally we had rubber bands mounted around here for compression on the balls when they're in this area. But what ended up happening was when there was a lot of balls piled up in this area, the rubber bands didn't have enough compression, so the balls would actually sort of pop out upwards and get jammed. And so what we did is we replaced those rubber bands with these PLA little like bars, and these have a lot more compression than the rubber bands. They can't really bend that much at all. You can see if I intake a lot of balls, they pile up into it really nice, and they don't sort of pop up at all.
So moving on to basically the end portion of our robot, we had our most prominent feature, which was our ability to be able to go under bar. We developed this design pretty early on, around December, November-ish of 2025. And a lot of people caught on, but a lot of people also had a ton of questions for us. So it's really simple. We just had 2 50mm pistons on either side of the robot, one there and one here. It's kind of blocked by the aligner right there. We had a standoff going all the way across each piston on the screw so it doesn't break. And we boxed it in like a kind of a reverse way where we put the metal contact, because like a normal boxing a half gut, you have spacers going in between, but by boxing it this way, you could have more metal to metal contact, which makes the surface area of everything stronger, and just everything is just more compact in general. This just made it really strong and stiff, and that's how we did undergoal. At Worlds, they actually screwed all of the goals into the ground, so we weren't ready for that because here are our underbar used to be like that high, but then with all the goals screwed into the ground, it was a lot lower. So at Worlds, we actually had to tune it to be like very low. And this is a lot more clearance than we would ever have, like maybe like half an inch of clearance, which was really, really annoying because for day 1 and 2 of Worlds, we basically couldn't go under the bar, which was the best thing about our robot and strategy. But we fixed it for elims, and then tragically our battery got disconnected, which sucks, but. And the annoying thing about building underbar is we wanted to have the same functionality as every other robot while also keeping the undergoal function. So the biggest thing you can see here is our descore wing. We took this concept from 21S. So thank you a lot to Oz for the inspiration. They made an explanation video too. You guys should check it out.
Yeah, go check. Yeah.
Yes, their double C is so cool. But I stole this design from them because I kind of had to build it really quickly because I built this the midnight before my first comp with this bot. And it's really simple. We just had one piston here that pulled this thing up with string routing through a bunch of pulleys. And then we had another piston here that was able to do top-down descore. That was just able to move it up and down. And then for our aligner, we had it, we used to have just like a screw with like spacers on it, but we realized this was bad because of how much the robot could twist and turn. So what we changed to was this piece of poly, where we got a C-channel here. I don't know how easy it is to see. We have a C-channel with 2 drilled standoffs, plastic standoffs on either end that we tapped. That way that it was really strong and this wouldn't come out. Even though they were plastic, it was boxed all the way through, and we used standoff retainers, so everything was really strong and rigid. At Worlds, we actually bent this top part off because what happened was when we would go into the goal, this piston has almost no leverage. Like as you can see, this is really easy to pull down, which wasn't a huge problem because the force wasn't going down as much unless we went into the goal at a steep angle like that. Then the entire thing would want to go down. So what we did was we bent our aligner at the top here, which made it so it wouldn't want to bend down as much because this stops it from going down by hitting this angled piece of poly, the angled poly part of the goal. And that made descoring a lot better and a lot smoother. And that was really nice. We just have string pulling it to be tight. So when we go underbar, everything can fold down. And then when we make this smaller, it basically fits into the profile of the bot. It sticks out a little bit, but it was mostly fine. So that way, when we were next to the goals here, this would hit slightly, but it would kind of just like bend back. So we had basically full clearance throughout the goal, which made our defense really good. Another thing that helped with defense was our wedges. A ton of people asked us about these. At Worlds, people thought they were logo blockers, but we had these since the Bots at Bristol competition, which, search it up, I don't know when that was. But the wedges were really, really nice for defense because they were able to prop up other robots and be able to just push them around easier. And it also made our drive base really long. So we were actually able to sit in a goal like that. And kind of like 3D4C's scoring blockers, we were able to just rest here. And then people weren't able to align into the goals because our robot was, this section of our drive was so long. So we were able to easily defend there. So that way we were able to jump to defend middle and jump to defend long goal really quickly with that. The wedges we had these hard stops so that it wouldn't bend back with this cool bend standoff thingy and drilled holes. We liked using drilled standoffs a lot. And then we use these custom gussets here made out of 3-wides just so that we're able to mount this at a high enough angle. And the most important thing about mounting wedges, because I think wedges will be really useful in override, so we're definitely going to implement them. And the biggest thing you need to do when you make your wedges is make your hard stops really rigid and really strong sideways too, because the hole in the high strength shaft for an 8/32 screw is almost the same size as the shaft. So what you want to do is have these fender washers here you can buy off McMaster, which makes it so at the top it's really wiggly, but at the bottom it limits the wiggle a lot. And that makes it so it puts less strain on the hole and more strain on the hard stop. And you just have to make the hard stop itself really rigid. We did this by practically boxing 2 half cuts here, putting a standoff in between. This makes it so this doesn't bend down like basically at all. And this is just really strong and rigid. So those are really nice for our wedges. And then we were also able to park backwards by just going up here. Our aligner could bend up like this, so we were able to go up the park berry backwards and forwards really easily. And the last thing I guess is we had we decided to do this this underbar design because some other teams like 883 AD, which is a really good team, they had an underbar design where basically the pivot point was down here and the entire ramp would just go up and down like that. We didn't like that because with their design, the intake was mounted on the actual ramp and they couldn't pick up balls when they were going underbar, which we thought was detrimental because the whole point of underbar, besides defense, is to be able to get balls like under the goal really easily. So we decided to go with this design, not just because of that, but also because with our underbar robot going down, these bars are actually parallel to the ground, which means we can have a mid-goal aligner on our bot here, which most underbar bots didn't have. This mid-goal aligner is just a built-on to our X-brace that we have at the bottom. This makes the bottom really rigid, and we just have rollers at the ends here, and then just half cuts that help align. And then our poly piece, this triangle shape or trapezoidal shape, also helps the aligning, because if we go to the mid-goal here, we can be off the goal like that much, and it'll align to the center just with the aligner. And if the hood doesn't go up, the trapezoidal shape can actually kind of align to itself in the center. I know these rollers are hitting it right now, but that was because at Worlds we had to lower it. It would normally be like this high, but The aligner was actually really nice for autons, where most mid-goal robots couldn't align, and we could. And also the fact that this leads into our intake ramp, we were able to go really far into the mid-goal like this, which means we can't really score in this position, but if we were this far in, people can't really push us. We're stuck on the mid-goal, and then we can just drive forward, and then we were able to easily score mid-goal like that. Balls can shoot through really quickly, but we just had a shift key on our controller if we wanted to slow the intake down, like that. And we were also able to score mid-goal just being in a position like this, where the balls were able to go through. We had standoffs here to descore. That way we just used less air overall. And the way we scored 7 balls in mid-goal was by just lowering our intake like that with these standoffs resting here. And then by using the shift key, the balls were able to just drop like that. And if I have a bit more balls here, oh, it kind of fell, but like, it wasn't the most consistent. Like I said, at Worlds, I wasn't able to get it, but for the most part, we were able to score 7 in mid-goal. Wasn't consistent at Worlds, could do it at other competitions, but yeah. So this is just our mobile scoring. To score 7, we lowered the match loader, so nothing would be in the way. We just raised the intake and we slowly output the ball. Just like that. It was really consistent at Worlds. We scored 7 and low for all 3 of our skills runs, except we didn't get long goal control or mid goal control, which is why we only got 94. Yeah, and then our mid goal scoring was also really good scoring fast. So like, let's say in a normal match setting, there'd be like 2 balls, I guess. If we had 2 balls in our intake, our mid goal scoring was really fast because this bottom roller is spinning at 1350 RPM. So we could just kind of just like shoot the opponent balls out while ours stay in.
So unlike Evan's design, we had this spot be a triple state. So it starts down like this, which is not good for middle scoring, but it does go under. And then we have a button to make it go to high. But we still wanted to like have a state to go to middle. And also we wanted less trouble for the pistons just when we're running around so we don't waste a bunch of air. So we also have a button, that's the wrong button. We also have a button for going in this middle state. And we did this with actually 1 piston on either side. So usually triple states have like 2 pistons per side and then 1 activates and then the other activates. And that gives you a bunch of states it can be. But how we did this was we have solenoids going from the top of the piston and the bottom of the piston. So we have a VEX solenoid right here, just because it was a little more compact. But basically, if the solenoid from the bottom turns on, then it pushes it up, and this solenoid would be off. And then if the bottom solenoid is off and then this solenoid is on, then it would retract. And then we have that 3rd state by turning both of these off, because then there's no air going through the piston. And we took advantage of this 3rd state by having these little levers right here. So these were hard stopped to where we want the lift to stop. Again, it needs new bands, so it's kind of floppy. But then we have this ball bearing right here that slides against this sanded down plastic just to be extra smooth. And then this screw in the middle is just like another secure point just to like get it to stop exactly where we want it. Again, kind of worn out, but.
And the screw head there, it sort of like rests on that, which allowed us to fine tune where it rested. You're just gonna have to take our word for it because I don't think Gil wants to replace those rubber bands, but it would actually rest consistently at that exact position when it's.
Yeah, it's true. It's true.
The middle state wasn't actually the best. Our middle goal scoring for this spot wasn't great because this was a 4-bar. The position from the bottom of this to the top of this like changes throughout. So when it's in the high position, these are closer together and then there's a lot of compression on the ball. But in the middle position, this is where this gap is the biggest. So there's just a giant dead zone right here. Like this is just like not touching at all.
Yeah, and for my robot, it was kind of the same thing, but opposite. Because when it was up, it had less room. When it was down, it had more like compression, which was good because when it was up, I was able to freely score balls. When it was down, it was harder to intake balls for my bot. But if I already had balls in the intake beforehand, before I went down, it was completely fine.
But since this middle state is less compression, if I just run like it just doesn't touch. That's why our middle scoring, this bot primarily did bottom scoring because it was a lot better. But we made up for it for the fact that the 24-inch was great at middle scoring.
This robot could score middle fine, it just needed to have more than a single block in it to get past that dead zone.
Yeah, and if a block started right here, then it had enough momentum to shoot across. And so for the wing, we want the bot to be in size with the wing when it's down, but then we want it to be as high as possible when it's up. And with just a normal piston right here, it will still be out of size when it's down, like that. So what we did was we made it on a 4-bar with one of the linkages being another piston. That way, we have this much movement just up and down for where we want the wing position to be. And then we also have this piston pulling the whole arm up and down. That let us have the ability to like start, what button is it? In size like this, and then we could go up here, and then also like midway for descoring. And that was pretty consistent. We never had problems with this going like too far down or anything like that. So I guess we had 2 triple states of different kinds on one bot.
And we found that style of wing actually works a lot better than the style that you saw on Evan's bot and that you will see on this bot, where it's just a little hook at the end. Because having a long wing that sort of has less of an angle change, it sort of just gives you better sort of purchase on the goal. It's more strong, it's more stiff, and just for a lot of reasons it handled and controlled a lot better. But we didn't end up having time or really enough of a need to replace it on this robot because this one worked fine.
Yeah, or just driver diff. Because like Lucas and I are like,
Yeah, I'm kind of good. You gotta watch me.
This guy sucked, bro.
Out of the 3 drivers here, I'm like coughing baby.
That might be true. It's okay, your bot made up for it.
Okay, so for the aligner, we have a different style than you might see on other bots, especially with high school bots. They all have like this plastic ramp.
me.
Like Evan. Since this went all the way down, we needed a gap right here. So there's just enough room like that. But also, when you have an aligner, let me drive to the goal. When you have an aligner, it's really only contacting the goal at like one specific point. So it being like plastic doesn't really matter too much that we found. So having this just be a print, like it was totally fine. We could change how like thick it is, how long it is, everything like that pretty easily. We just had to reprint it. And then everyone asked like why it was curved on the bottom, like right here, just for looks. Just because I think it looks nicer than just a straight like a rectangle. We did have these mainly as hard stops. So if you look when it's up, this like point just stops it from pivoting too much. But we also had a hard stop down here with a fender washer. That it just did the same thing. It just like contacted when it had too much twist, just to make this movement as little as possible.
And that's important because since it's part of the linkage, it's only mounted on 2 screw joints, and so without that, this would have a lot of twist back and forth, and we were worried about it bending or just getting stuck somewhere because it could bend so much.
The more it bends, the less the ball moves, because more of that movement goes into the arm. But this was totally fine.
Yeah. Like for my bot, this is Evan by the way. For my bot,
Hi, Evan.
I made bring my robot really quickly. I made mine kind of the opposite. I didn't have hard stops. I made it like literally as rigid as I could possibly make it. This is all screw slop because I have half cut, structural screw joint, half cut, box through, then 3 wide gusset, so it's vertical, and then like a triangle brace gusset there. So mine was like literally as rigid as it could be.
Yeah. Again, we couldn't really do that because there's just so much happening with the 4-bar here. What was the other thing I was going to talk about? Oh, so because again with sizing is just the greatest challenge on this bot. We needed the hood to come up at the start of the match, but also when the match loader comes down, because if it's just like this, then here to here, that's way more than 22 inches. So we have it on a piston connected to the same solenoid as the match shoulder, so that this comes up when we want it to. But that means when we start the match, for this to be up, this needs to be down. But if you've seen it start in size, let me get it quickly in size. If you see it start, like this is it in size right now. We had to find a way to keep this like up while still like thinking it's down. And we do that literally with the intake just wedging itself, and it keeps it pretty nicely compressed. And then when we intake, the flaps just flip it. This catches, like I said before. But what I didn't want is I didn't want when we were carrying it and for when the bot was off, for this to just be out, because that would be really annoying if like when we're going to a match, this is just like loose. I didn't want to get caught on anything. So when I turn it off, the code's not running. It wasn't running when I turned it off. This actually goes up. And we do that with, on the Vex solenoid wires, there's a green, like one of the two wires, there's the green one. And that powers the solenoid when the bot is on, not when the code starts. That way the solenoid isn't powered right now. It doesn't know to activate. But then when I turn the bot back on, the solenoid gets power, that wire activates the solenoid, and then this goes down, and the code is not on. So that was a little thing we did just to be a little nicer, like not in matches. So with bottom goal, we did a few things just to make it a little nicer. One is that this goes all the way into the bottom goal like that. And then the other is that we have a big gap here. Evan has a similar thing, but this gap was too big for the ball. It actually doesn't touch. So we added these little smaller ones. And bottom goal was really nice. I kind of wasn't aligned there. Sometimes this would get shoved up from a ball and then get caught on this, and then like, that's the wrong button. And then like catch up like that. But we have anti-jam, so it would just release back down.
Anti-jam.
Anti-jam. Shout out Jordan21.
Yes, I have that too.
So that really wasn't a big deal. The last thing I want to say is that we have our IMU on a wiggly mount like this. A lot of people were asking about that. It's just to mitigate like how much vibration goes into the IMU. If you do this and check for yourself, it's very good. It like just removes a lot of noise. Also, a lot of people wonder why, you know, we don't do full custom and like why this is all Vex stuff. A lot of it's for modularity, but also we're kind of just broke. So this is a lot of like stuff we already had. It's only 3 of us on the team, or 4, I guess. So we just kind of reuse whatever we can. And also, honestly, if we did any other design than Undergoal Rugon, we would have done much better. If we were good, we would have done, you know, 1 lever, 1 S, or both lever, or whatever. But this is much more fun, I think.
All right, so this robot we actually built first. I think out of the 3 robots here, this is the oldest one. And so it's a little bit primitive, especially in terms of the triple state mechanism. We originally did the triple state mechanism on this so that we could have the intake at the front, because like I mentioned earlier, we wanted to do double intake, but we couldn't really fit it like an intake down there and scoring here for middle, and like have it be able to go up to score for the high while still being able to go under the long goal. And so we did this triple state mechanism back in September. And the way we did it, we just did a simple 3 piston 2 piston on each side mechanism. So these front pistons are mounted on these levers back here. And if these front pistons fire, oops, that's the wrong button. They pull it to the middle position. So you can see these front pistons are fired, but these back pistons are not. The back pistons are just neutral. And so this is able to score quite well in the middle goal, but it can't fit under the long goal, as you can see. Let me just get some balls in here. Like that. And also in this middle position, because it's got a little bit of flex up and down because the pistons are able to move a little bit down and up, They sort of just act like springs from the pneumatic pressure. We can actually descore middle goal really well and sort of eat the whole thing the same way that Evan's bot can, just like this. And when we're like this, I actually did this during auto. It's basically impossible to score more blocks than like 2 extra, maybe a third. So if we scored like 3, if we scored 3 blocks in the middle in auto, we are like guaranteed possession if we just sit here.
That worked great, very consistently at Worlds.
Yeah, that was honestly like more consistent than my tall goal scoring somehow, in auto specifically. And additionally, because the intake is like goes in so like far, like I can like drive in like all the way this far. My logo descore is actually also pretty good because I can just do this and like it's gone. And then if these back 2 pistons fire, they pull this lever back, the lever that this piston's mounted on back, up like this. And so it goes to the high goal position like this.
Oh yeah, I still have to show my scoring. But this
Yeah,
is my robot.
I do too.
The scoring isn't as good right now because I think the robot got bent in transit back. We didn't really bother packing it well, but that's all right. This was able to hold 8, maybe 9 balls.
6 or 7.
Thank you, Evan. It could hold 9 balls, but it was a little sketchy with 9. It would jam sometimes, but it held 8 quite well. And we were able to dump sort of in a few matches, but we didn't end up using it that much because we were more fans of protecting like descore, protecting the balls we already had in the end of the match. But there was a few matches where I dumped, and it worked quite well. So this is our wing, our descore, and all of that stuff. So the first thing I want to mention here is this, which is our sunroof. Actually, it's not a sunroof, but everybody thinks it is for some reason. I guess it kind of looks like one. This is actually our descore liner. So this is kind of unique. We had to do it a different way because we needed to fit this very compact so it would be, you know, able to fit under goal. And so this piece of plastic flips up like this and it has these rollers on it. These are 3D printed. They can actually rotate. And you can see that they sort of catch in this corner of the goal like that. And the rollers roll along it, and this works very well as an aligner. As you can see, it aligns quite well from quite a few angles. And we have the piece of plastic also has this sort of weird angle so that we can bias towards the goal, and this keeps us connected to the goal while we're descoring, as opposed to if it was just straight, where if the robot doesn't drive perfectly straight because, you know, maybe I'm not holding the sticks perfectly straight or it wasn't lined up perfectly at the start, you would kind of drift away from the goal, and that could be a problem. So we sort of bias towards the goal so we always stay connected to the goal while descoring. All right, so other than the aligner, we have our descore hook, which is pretty much very similar to the normal 21S hook. So you can see it just goes down and up with this little piston here. You can ignore this stick, I'll talk about that later. We have this little sort of sled that stops it from getting caught on this corner of the plastic here, and also on the edge of the plastic here, and that works quite well. And the actual descore hook is made out of 6061 aluminum high strength shaft that we bent by making a 3D printed form and hammering it around the form so that it makes a perfect circle. And this way, this it's perfectly concentric to the point that it's pivoting around. So that means that it doesn't have any sort of side to side movement when it goes in and out. And that makes it so that we have the widest possible range where it can go in from. So like it can go in from back here, and it can go in from all the way over, even if like this is down, all the way over here. Although it would never actually go that far in because of the descore liner. So we have like a whole 1.5 inches of space where the robot can be, where the descore will successfully work. And then when we're not using this, it can fold all the way back here. And you can see it sort of folds into this little crevice that we have back here behind these rollers. And so it goes all the way down, and that way it's basically flush. It's flush with the top of the robot, so this can go under goal. But unlike a descore that comes up from the side, we can still put it up if we're like right here and we want to do like a really quick descore. We can put it out like this, Whereas if the descore came out from the side, it would sort of hit the bottom of the goal and we would have to like drive out first. All right, and then the last thing on this wing that you might be confused about is this little stick here, or wall, or I like to call it the ragebait mech. And you can see it's very simple. It's just a piston here. This is kind of a weird piston that we borrowed from CSUN.
Shout out CSUN.
Yeah, shout out CSUN, we love those guys. But you can see it just goes up and down like this. And what this is it's a goal blocker. So what we do is we put it down and it sits right there. And you can see this is not goalkeeping because it's not actually inside of the goal. But it can't be pushed forward because of this little vertical section of the goal right here. It catches on that, so no matter how hard you hit this, it won't go up, it won't go in. And this completely blocks people from scoring. So we're gonna have Evan go ahead and drive the robot around.
At the end of the match, when teams are trying to dump, Evan has 6 balls. This confused a lot of people at Worlds. Everyone thought their intake was jammed. Because it's black, it's kind of hard to see, especially when you're, you know, over there.
I got it.
But it was, we used it like every match. It was very, very good. This was like very, very late game tech. We got from
we stole it from 334C. Shout out Arrow.
334C. But
favorite world champion.
Because it was so late in the game, no one in Vexy really had it, and those that like knew about it didn't really think it would work well.
Yeah, something kind of funny is BLRS, the last team that we beat at Worlds, they told me, one of the teams that they mentor saw this on our robot and sent a video to them. And they told me before Worlds that if we used it against them, they would just break it. And they tried to, and it didn't work. Well, the stick worked correctly. They tried to score against it, and they couldn't score.
Yeah.
So that was a really funny part of our robot.
The only downside is that we didn't put it on the 15-inch, and we didn't, put it on sooner because we could have had more practice with it. And
yeah, that was literally a 2 weeks before Worlds thing.
Yeah. But definitely saved up. I mean, like all of our matches are, all of our calls were like super not close, and it's just because like no one could dump at the end because we had that.
Thank you, Evan. The coolest and most important part of this robot by far is our zip tie for autonomous. It starts shoved under there, so we are touching the parking barrier, but we don't have to actually be touching the parking barrier. And the reason for this is actually not so that I could get closer to the goal, or closer to the balls for like rush or anything. It's just so that we could always start in our robot in the same position relative to the field tiles without having to worry about something actually like hovering like far over the parking barrier, because no matter where our robot is, we can just like kind of shove that into place so that it's legal.
Especially with the parking barriers, they're like super inconsistent at like where they are.
Yeah, sometimes they're like a full 2 inches like further off than like we expect them to be.
And then we're both going to demonstrate our scoring. We're both going to score 8, but it's not the best with 8 for either of us, I think. Yeah, so score. Yeah,
good enough.
My intake jams kind of. 7 is really consistent though, if you want to score.
And the 24 can do an 8 dump too. But as I mentioned before, the scoring got damaged in the ride back from Worlds, so we don't really care enough to fix it.
7.
Damn! That's pretty good!
Damn!
Sure. Oh my god, Gil's just better. Oh my god.
Oh my god, sorry.
No, I'm keeping this in. This is gonna stay in now. You're living with this.
That's fine. Stop. Okay.